Right, so given a polynomial here, let's take a look at this image. So the polynomial is x to the power of 5, 2x4. One root of this polynomial is 3i. Express p of x as a product of 5 linear polynomials. So essentially we just have to find the roots of this polynomial. So I'll write out the equation. Okay, so x to the 5, 2x to the 4, positive 6x3, 12x squared, negative 27x. Okay. So we have x to the power of 5 plus 2x power of 4 plus 6 plus 6 x cubed, and then plus 12 x squared plus, sorry, not plus, minus 27 x, and then finally minus 54. And the question is telling us that one of the roots is equal to x is equal to 3i. So knowing this, because we have an imaginary root, we can also say that the conjugate is also a root. So whenever we have an imaginary root, we know that the conjugate is also a root. So imaginary roots are always expressed in this format, so a plus bi, and then the conjugate is always a minus bi. So in this scenario, we know that the conjugate of 3i is negative 3i. So actually, the question helps us infer two roots of this polynomial. So knowing that we have 3i and negative 3i as roots, we can write that out over here. So we know we have x plus 3i and we have x minus 3i. We can also simplify this even further to the difference of squares. So we can recognize that this is the difference of squares, and essentially get that to x squared minus 3i squared. So we don't need this bracket. Okay, so the difference of squares is just the standard formula. So any value a squared, let's say this is a squared minus b squared will give us a plus b times a minus b. So in this scenario, a is x and b is 3i. So once again, a squared minus b squared always equals a plus b times a minus b. So that's the standard formula for difference of squares. We can also define what I is. I is the imaginary number for the square root. I'll write that a little better. So the square root of negative 1. So knowing this information, we can kind of square the 3, which will give us 9, and we can also square the I. So the square of the square root of -1 will just give us -1. So here we can say x squared minus 9, so 3 squared, times I squared, which is just -1. So I squared is -1. And then since we have 9 times -1, we can just turn this into a positive sign. So we have x squared plus 9, and we know that we can factor that in to this polynomial to get the roots positive and -3i. So let's erase this down here. So we can use x squared plus 9 to do some long division between this polynomial and x squared plus 9. So I'll erase this over here, just so I don't have to rewrite the equation. I might have to rewrite this a little smaller. Okay, so let me just clear the board. Okay, and essentially we want to do long division of the following. Okay, so we're going to divide x squared plus 9 into the initial polynomial. Because we know we can divide this into the polynomial and get no remainder. So we add x power 5 plus 2 x power 4 plus 6 x cubed plus 12 x squared minus 27 okay, that's 7, not work with 7, so we'll write that again. 27 x, and then finally minus 54. Okay, so we have x to the power 5 plus 2x to the power 4 plus 6x to the power 3 plus 12x to the power of 2 minus 27x minus 54. So to complete long division, we have to think about what can we multiply x squared, so this value, to get x to the power of 5. So we can multiply this by x to the power 3. So we can write x to the power 3 above. And then we can, since we multiply this by x squared by x to the power of 3, we get x to the power of 5. And then we also multiply x to the power of 3 by 9. And that is what we get. And then we subtract the two polynomials. And then this will give us, so the x to the power 5 and x to the power 5 get eliminated. We still remain with 2x power 4 plus, actually minus, because we have 6 minus 9, so 3x minus 3x cubed plus 12x squared minus 27x. So just the remaining of the polynomial. So just give me a second to write this down. Okay. So we figured out what the first term was in our division, and that's x to the power 3. Next, we look at this term and think, what can we multiply x squared, so this term over here, to get 2 to the power of 2 times x to the power 4. So I'll underline these two terms in red. So we're looking at this term and this term. So we know we can multiply x squared by 2x squared to get 2x to the power 4. So write 2x squared above. And then we'll subtract. So x squared times 2x squared will give us 2x to the power 4. And then 9 times 2x squared will give us 18 to the power of x times x squared. And then we just subtract these two polynomials. So we know we get 0 in the beginning, and then we're left with negative. I'll write this over so we get 0 for these two. And now we get negative 3x power 3. And we have 12 minus 18, which will give us negative 6 x squared. And then we have the rest, so negative 27 x minus 54. So finally, or not finally, there's two more steps still. So we think about the negative 3x cubed and the x squared. What can we multiply by x squared to get negative 3x cubed? We know we can multiply by negative 3x. So we'll write negative 3x up here. Okay. And we'll do the multiplication down here. So x squared times negative 3x will give us negative 3x cubed. And we also have the 9. So 9 times negative 3x is negative 27x. And then we subtract the two functions. So we're left with 0. And then we also have the negative 6x squared. Then negative 27x minus negative 27x is also 0. And then we have 54. Finally, to find the last term, we know we can multiply x squared by negative 6, so I'll put negative 6 up here. And so negative 6 times x squared will give us negative x squared, negative 6x squared, sorry. And 9 times negative 6 is negative 54. So we can see that these just cancel out and we get 0. And we get 0 for the remainder. So we successfully divided out x squared plus 9 into this function, and we got the polynomial that we're looking for. Okay, so I'm going to erase most of this stuff so we can go on to the next thing. I'm going to leave the important information that we've solved so far. So I'm just going to make this a little bigger. Okay. So we're left with this function. Put it in bracket. And we'll erase this and put it up here. So we know this function is equivalent to the given function at the very beginning. We have x squared plus 9 multiplied by x cubed plus 2x squared minus 3x minus 6. So the next step we want to do is think about this part of the function and see what kind of factors we can, or what are the roots of this function. In order to find the roots of this function, we can do the rational roots test. So the rational roots test is essentially as follows. So we look for plus or minus factors of a naught. So factors of a naught, I'll just write f for factors, and then divided by factors of an. So a naught just represents the final term over here. So a naught just represents -6. An represents the coefficient with the highest power, so 1 here. And we look at what kind of numbers we get from this. So just writing these out right away. So we know for 6 factors of -6 are 1, 2, 3, and 6, plus or minus. And factors of 1 are just 1. So we're going to look for, so if we divide 1 by any of these, we'll just have 1, 2, 3, and 6, and then we have plus or minus. To find a root of this function, we're going to substitute 1 at a time. So we'll substitute 1, -1, +2, -2, -2, +3, -3, +6, -6. And then whichever one gives us this function equivalent to 0. So if we substitute that value and we obtain 0, that is one of the roots of that equation. So we can start off with, let's say we can start off with 1. So if we substitute 1, so let's call this function f at x. So we'll say this is, just erase some of the mess over here. So we'll say, we'll call this f at x. And we'll evaluate for these values. So let's say f at 1. You can plug this into your calculator to make it a little easier, but we can also do some mental math. So 1 cubed is just 1, plus 2 times 1 squared, which is just 2. So 1 plus 2 we have so far, minus 3 times 1. So 1 plus 2 minus 3 minus 6. So 1 plus 2 is 3, minus 3 is 0, and then -6. So this gives us -6. So we know positive 1 is not a root. We can also try other values, and if they give us something other than 0, then we know it's not a root. Let's try -2. You can also try -1. And +2, but I know -2 for this function will work. So if we substitute after the -2, -2 cubed is just -8. So 2 times -2 squared. So we know -2 squared is +4 times 2 will give us +8. So whenever we cube a negative number, we'll get a negative number, but if we square a negative number, we'll get a positive number. And then we have -3 times -2, which is +6. And then lastly, -6. So we know the 6's cancel out, the 8's cancel out, and we're left with 0. So we know x equals to -2 is a root of this function. We'll clear the board out a little bit. Okay, so we know that x minus +2 actually So x equals -2, therefore what we can factor out is x plus 2. So there's the positive sign instead of the negative. So, but we know x minus 2 is one of the roots. This is how you just represent it when you're putting it in the function. So we can use this to do synthetic division on the function. So to do synthetic division, I'll go through the steps one by one. So you place all the coefficients of this function on top. So I'll say 1, 2, -3, and -6. And then we'll put the root over here for -2. So the first thing you do is you bring down this value, and we'll write it down here. Then we'll multiply 1 times -2, and the result of that is -2, and we'll write it over here. Then we add 2 plus -2, and that will give us 0. And then we do -2 again, times 0, and that will give us 0. And then we add -3 plus 0. This gives us -3. And then finally we do -2 again, times -3. And then this gives us +6. And then we add -6 plus +6 will give it 0. So we get up, this value represents the remainder, so the remainder is 0. And we know that we're left with x squared. So this column represents x squared, this represents x, and this represents just the constant. So we know x squared plus 0x, which is just 0, minus 3. That's the solution for dividing x plus 2 into this function that I have underlined up above. So far, when we factored out for our equation, we have x squared plus 9. We have x plus 2. And we also have x squared minus 3, which is what we solved for right now. So the question is asking us, we need 5 linear polynomials. So we need to have all exponents to the x to the power of 1, so no x squared. So to simplify this even further, we know x squared plus 9 represents the roots positive and negative 3i, so we can say x minus 3i. And then we also have x plus 3i. And we have x plus 2, which is in the correct format. And then multiplied, so dot for multiplied. So I'm just continuing on from over here. I'm just going to put the rest down here. So we have x squared minus 3. So x squared minus 3 is a difference of squares as well. We know to solve for this, we'll end up x minus square root 3. We know square root 3 squared is just 3, which is this value, and then x squared is just x, so this is just the equation for difference of squares. And then x plus square root 3. And that's the final equation for the solution. So we expressed the equation as a set of 5 linear polynomials. Linear just means that x will be the power of 1. So each part of the equation is the x to the power of 1. So we have 5 roots. We have x is equal to plus or minus 3i, x is equal to plus or minus square root 3, and x is equal to negative 2. So let's look at the solution here to verify. So first, because it is okay, so this is an incomplete solution. So incomplete solution correct answer is x plus minus 3i, x plus 3i, x plus 2, x minus square root 3, and x plus square root 3. And the solution is incorrect.